Hey, today I want to make with you a continuity problem. In this case, what we're going to do is we're going to find in a piecewise function a constant a that if we assign a specific value to it, will allow that function to be continuous at a breaking point, okay? So now let's do that problem. So first of all, we're going to define a function. We're going to say we have the function f of x is equal to, this is a piecewise function. So we're going to have x cubed when x is smaller or equal than is smaller or equal than 2. And we're going to have a quadratic function a times x squared when x is greater than 2. These are our conditions, okay? So now what do we need to do? Well, first of all, what we need to do here is we need to find a, okay? We need to know what constant a will allow the function f of x to be continuous at our breaking point. What is our breaking point? Well, if you remember our last video, or maybe if you didn't see it, a breaking point is that point when in a piecewise function, the p's that you're going to follow will switch, okay? So in this case, when we're going with values smaller or equal to 2, well, we're going to follow this function, x cubed. But when we switch to values greater than 2, you will follow this function, okay? So 2 is our breaking point because the function will break at that point because we're going to start following different functions. So our breaking point is 2 in this case, okay? Now, what do we need to do with this information? Well, when you're doing calculus problems like this, you need to use definitions. What is the definition of continuity? Well, we know it is when the two limits approach the same value in a function, and that value is the same as if we evaluated a function in that value, okay? So, with this information, what we can do is set a limits definition. So, we can say that the limit as x approaches our breaking point, which we know is 2, and now we can say this happens from the right side. So if we know it is the right side, that means values bigger than 2, that would be ax squared should be equal to, because remember we're doing the continuity definition, should be equal than if we approach 2 from the left side. So that would be values smaller than 2, which is this function. So it would be the limit as x approaches to from the left side in the function x cubed. And now these two things should also be equal to f of x evaluated at x equals 2. So it would be f of 2, okay? So now let's try, what do we need to do so that this equation is true? Well, these two functions must be the same when they approach 2, okay? So we need to find what value are they approaching to when x gets closer and closer to 2. So let's do that. So we know to solve this limit, we can just do direct substitution. So we would have ax squared is equal to x cubed, right? So we need to first, if they share the same limit, that means that the two functions have a common place or a common order pair in which you plug in an x value and you get the same y value. So we set this equation right here. Now what we need to do is plug in 2 because we're finding the limit as x approaches 2, and we don't need to do any factoring. So we would get a times 2 squared should be equal to 2 cubed. We know this would be equal to 4, so we would get 4a should be equal to 8. Now divide by 4 on both sides, and you're going to get that a is equal to 2. So now that means that when these two functions meet, they will only do it when a, our constant in the quadratic function, is equal to 2. This is our answer, okay? It's a pretty simple problem. This is the value we're looking for. A equals 2. So now let's see if that is true in this case. So we would know if we plug in 2 into that a, we would get once again 2 into the x, so it would be 4. 4 times 2, that is equal to x. That is equal to 8, I'm sorry. 2 cubed is also equal to 8. So these two limits meet in the same point, and now what is the function evaluated at x equals 2? Well, we know, if you see here, when x is equal to 2, we're going to follow x cubed. And we know that x cubed is equal to, well, when we plug in, that would be 2 cubed, and this is equal to 8. That means that 8, well, is also equal to f of 2, f evaluated at 2 would be equal to 8, which is the same as these two limits. That means that a needs to be equal to 2, so this function can be continuous at x equals 2, okay? So this is the entire problem. I hope that you can see it is pretty easy. You just need to make two functions equal each other, which is the two pieces that you have in your piecewise function, and that is everything you need to do. In the following video, we're gonna do a problem where we need to find two constants, okay? Not just one, which is what we did in this case. So I hope you guys enjoyed the video, and see you in the next one.